All right. So the goal here today is to look at how we can compare a exponential to a linear function. And we're going to use Desmos again to do that. So you can see here on the left-hand side, I've got a table of data. So our first step is to create that table in Desmos. So I'm going to rock and roll through that pretty quick. So I have 0, 1, 2, 3, 4, 5. Oop, not 45. All right. And then here on the left, we have 50, 38, 30, 25, 22, and 20. So the question really is when we look at this data, which I'll go ahead and zoom out here a little bit so you can see it. When we look at that data, we can see what's really going on. We can say, hey, yeah, there's kind of a pattern there. We can see that it's definitely decreasing. Um, and we can start to see that curve happening, but we're not exactly sure this is exponential yet. So we don't want to just rely on the naked eye to really determine if this is exponential or linear. So what we do is we're going to use a similar skill to what we've already learned back in Unit 1. We're going to create our linear regression line to begin with. So remember that what we typed was we typed y1, and then we typed our tilde or the squiggly line, which means approximately, and then linear is mx1 plus b. So as you remember from Unit 1, that now created our exponential our linear information here. So you can see here our R value, here's the M, here's the B. And you can see that, yeah, it looks like a pretty good line, that purple line, for the data points. But let's see if exponential is any better. So if you remember, one of the most important things in this information is this R value. This R value is the quantity or the measurement of how good a relationship it is. So negative 0.95 is pretty good. I know it's negative. That's simply because it's going in the negative direction, but it's really close to 1, which makes it a really good relationship. Let's see if exponential can beat it. So if we're going to type this in an exponential, it's going to use the exact same form, y1 tilde or squiggly line, but instead of mx1 plus b, now our new form is a times b raised to the x. So I'm just going to type a, b, and then raised, which is shift 6, raised to the x1. So the very first thing I want you to do, you can already see the exponential function was created. But before we do anything else, without explaining, I want you to click this button right here, log mode. Turn log mode on because it goes into further things that you don't need to understand at this point. But we want to use log mode to compare these two functions to each other. So now let's take a look. We can visually see that our black line definitely is exponential decay, and it's starting to follow those blue points. But how do we know which one's better? We know which one's better by looking at the R value. So we already talked about our R value up here, negative 0.9525, versus our new R value for exponential is negative 0.9825. The question you have to ask yourself is which of those is closer to 1? And it's definitely the negative 0.9825. So our conclusion is that the exponential model is much better than the linear model in this case. It's a better fit, it's a better relationship. So we would then create this equation. Our equation would be y equals this 46.2223 times b, which is 0.8328, all raised to the x power. So you can see that black and red are pretty much the exact same line. So there's your exponential function. Let's try it one more time for a new set of data points. I'm actually going to leave these here because those are going to be our same things, but let's change our data. I'm going to create a new table here, almost the same, but all of these, we're going to change all of these. So 50 stayed the same, but this is now 42. The 30 is now 35. The 25 is now 26. The 22 is now 20. And the last one is now 12. So you can tell me what you think. Does the black line still better? Is the purple line better? But all we really care about, again, is the R value. So let's compare our R values to each other. Negative 0.9992. That's almost exactly -1, which is really, really, really close to being perfect. And then this is also great, negative 0.98, but clearly, just by a hair, the negative 0.9992 is the better relationship. Our function is more linear than it is exponential. So this is one of our new skills, to be able to use exponential and linear regression and compare the two to each other. And Desmos makes it really clean and really easy to see them side by side and to really get some concrete data as to which equation is best. So that's our steps there to really compare, create your table, and then create our two regression equations, both of them using the squiggly, the tilde line. Y1 is approximately mx1 plus b, and then y1 is approximately a times b raised to the x1. Do not forget to turn log mode on. It's very important that you do that. Don't worry about why at this time, but make sure you turn log mode on. That'll be important to get accurate data. All right, folks, hopefully that helps in determining which is better, linear or exponential.